HashiTalks. Can we share? There we go. I thought that was already up. Okay. So just a fun fact about myself. I once had the phrase automated test fanatic on my business card. So if you're wondering, I think very highly of automated testing. I have since taken it off my business card. I actually don't have business cards anymore. But I think very highly of it, but I am very, very much less dogmatic about it. I want to make sure that we are testing the right things, spending the right time in the right place. And I think there is a need for a happy balance between testing and actually being able to move fast. And so I do think there is a place for automated testing or even manual testing in pretty much everything we do, whether that is learning a new framework or building a high scale app for the cloud. And again, like the thing that we're going to talk about today is like figuring out how to find a happy balance between what kind of testing is right for the situation and how much to do. So let's just review what infrastructure as code is. It lets you automate deployments of your infrastructure. And this lets you facilitate both scaling and quicker repeatable deployments. The best part about this is that it's also code. And this means that you can version control it, you can code review it, you can test it, and you can push it through your CI/CD pipeline, the different stages. So I'm sure you've all earned this badge, the Works on My Machine badge. I certainly have. And with infrastructure as code and working in the cloud, there's more that can go wrong when we are working on more than just our own computer, our own machine, our own very narrow space of an environment. So when we are pushing changes to the cloud, whether that be through infrastructure as code or it's even manually, there is a larger blast radius here. And instead of it just, if it breaks, if something does go wrong, what ends up happening is it might not work on, it might work on your machine and it might work in your account and it might even work in one region that you're working in. But if it's broken and you push it into a different region or a different account, you aren't going to catch that until you've actually provisioned that software or those resources. So you have more resources, more regions, more customers, and more dollars that are impacted when things do actually go wrong. So it's not just an isolated occurrence. So in the next 25 or so minutes, we're going to talk about treating your infrastructure as code as actual code and minimizing that blast radius. We'll talk about the different types of testing, using test-driven development to make sure you're building what you need and only what you need. We'll talk about testing your infrastructure directly, so testing what's actually provisioned in your account or in that region. And then we'll talk about integrating all of this into a CI/CD pipeline. So we know that the cloud makes it a lot easier and quicker to provision our infrastructure. But again, like I mentioned, there's complexity with that scale. So maybe you're writing infrastructure code to replace all your EC2 instances with the latest Graviton 2 instances. You've tested it in your AWS account, and then you go to push it to the production account. And something goes wrong. So in this case, the EC2 limits, maybe they haven't been increased for that custom AMI, or maybe it's not even available in that account. So either way, we have to roll back our changes and try again. So infrastructure as code is one way that we can manage that complexity, especially at that scale. Automated testing is yet another way. So with automated testing and bringing some of these software engineering practices to our infrastructure, we're able to build quality in from the start, just like we would with our application code. Now, when we talk about bringing testing to our infrastructure, it's still important to consider the different types of testing that we're going to use. So just like we do when we build this test strategy for application code, we're going to do something very similar for our infrastructure code. This here is a variation of the testing pyramid. It's been around for many years. And the tests at the bottom of this pyramid are going to be cheaper and easier to create and to maintain. They also give us quicker feedback. And this is as to when something goes wrong or when something does actually go right. And so they're more fine-grained. They're testing one small chunk of logic or configuration. And that's why it's called a unit. So one chunk is one unit. The tests at the top of the pyramid, those are going to be more expensive to write. They're more expensive to maintain. They're also often more brittle. So in the case of our infrastructure tests, they are going to be more complex because it involves spinning up and tearing down actual resources in the cloud. So with our unit tests, we are testing the actual code itself. We're not actually testing resources in the cloud. With integration tests, we are actually creating those resources and testing those directly. Again, like I said, tests at the top of the pyramid are more expensive. So manual tests are going to be the most expensive. They're most time consuming. And we want to not have as many of those. We want to have a balance of the fast, quick, cheap tests with the more expensive tests, or the ones that are more closer to the actual infrastructure that we are going to be using in production. So those that are at the top are going to reflect reality a lot more, but they're more expensive when it comes to our time and dollars and just maintaining that. And so that's why we have to have that balance. So if you're test driving your application code, why would you not do the same for your infrastructure code? The benefits of test-driven development include reduced defect rates. There's actually research out there that talks about specific numbers. I don't remember what they are, but there's research that talks about how test-driven development can actually lower the number of defect rates that you're seeing. And it brings them earlier in the process so that they aren't as impactful as if you had found that defect in production. It also improves the overall design of what you're building because you're doing it in increments or iteratively. Keeps you focused on requirements so that you're building only what you need and when you need it, and nothing more. When you're building extra things, the nice to haves or what's not actually a requirement, you tend to find more defects in that area because it's not what you actually needed. It can also, it keeps you focused on smaller chunks, those units that we talked about. So it can make sure that those pieces actually work independently of each other. And then it also serves as documentation for your team. So a lot of times when I go into a new code base, the first thing I look at is the unit tests or any other tests that are there, just to see. I'm also looking to see if there's any sense of the quality that the team is adding to their code base, but I also am looking to see what functionality is supported, what the features are, what the team thinks are the expectations of those requirements and of that code. And then finally, test-driven development gives you confidence in what you're building. So it gives you the confidence to be able to refactor something. It gives you the confidence to be able to build new, whether it's new infrastructure on top of your current set of resources, or it is adding new logic or functionality to an existing application. So this is the test-driven development flow. You can follow the same red-green refactor flow that you would when you write your application code. So the way this works is you start with a failing test. So you write that failing test. You get it green by writing only enough production code to make it pass. And then you make it better by refactoring it or adding the actual functionality that you're trying to implement. So in the examples that I show in just a minute, we're going to go through this process so you can see how it works, both with unit tests and even with some integration testing. So what is a unit test? Let's talk about that. These are the tests that are going to be at the bottom of that testing pyramid. They are the cheap and fast tests. They are quick to run. They're quick to give you feedback. It exercises a small part of your application or your infrastructure, so one unit, and verifies that it's correct. They, like I mentioned, they're quick. They can be run frequently. So if you're running them locally on your machine, you get quicker feedback for your local development processes. They help us communicate requirements to our team, and they can also be run in your CI/CD tool. Now, traditionally, these unit tests are isolated from other resources, so or external APIs. So what that really means is if in the case of when I'm testing my application code with a unit test, I'm not going to test the boundaries of different classes or objects, or even go to the point of testing how my application is using the database and testing that connection and querying and manipulation. I actually just want to test how it's interacting with those, or I want to test even a smaller unit of that is how what the logic is doing within the context of that one object. So we are trying not to test across those boundaries of external APIs. And that can be whether that's a REST API or a database. We are keeping that very isolated. And that's going to let us reduce the scope of what can go wrong and the number of variables that impact what can go wrong in our test. And then finally, I just want to mention, like, if you've ever provisioned an RDS database, which I have done multiple times recently, it takes several minutes to do. And if you do it wrong the first time, whether you're doing it manually or even in your infrastructure code, you have to wait. You write the code, you apply it or spin it up, and then you have to sit there and wait for it to actually provision it. And if there's something wrong the first time or multiple times that you're going through this, you have to go through that process multiple times, the waiting process. And so that can be really time consuming. And that's where these unit tests can come in handy, is we can write a unit test to verify that we are setting up this database according to what our requirements are actually looking for. So we can actually do the same thing for our infrastructure code. We can apply the same process, unit testing, test-driven development. We can apply that to our infrastructure code. And with unit testing, we can do that because it's code. It's not actually in infrastructure at this point. We don't need to provision all of the resources in order to test to test what we are trying to build. Just like with our application code, we don't need to have that database sitting there in order to write tests against maybe a CRUD API. So yeah. Now a unit test, we've talked a little bit about this, but a unit test is going to test if a resource is created with the correct configuration. So in the case of infrastructure unit tests, we're talking about the configuration of a specific resource. With application code, it might be the logic, or it might be how you configure inputs into a function call. But with resources, it's oftentimes it's going to be the configuration. It can also be the correct whether or not the correct number of resources have been created. So in my examples that I'm going to show you in just a minute, I'm essentially creating one of everything, just for the purposes of time. But our infrastructure code allows us to create multiples in order to scale. So for instance, I might need to create 5 different EC2 instances or 5 of the same EC2 instances. I can make sure using my unit tests that I'm doing just that, that there 5 have been created and that they are configured correctly. We can also test that dependencies between resources are created correctly, and then also interpolated values as well. So in this first demo, I want to show that it is possible to test drive your infrastructure code. So for context, this is a cloud development kit app or a CDK app. We want to create a private S3 bucket with encryption enabled by default. So it's a very simple, small use case. And we are going to write the infrastructure code with we're going to write the infrastructure code with the CDK code, and then we're going to make sure that our test passes. So we're going to use the Jest framework for the unit testing. And while this demo is written with the CDK, you can also do this with other frameworks. So you can write unit tests with other testing frameworks against other infrastructure as code frameworks. So that could be against a Terraform plan representation, or it could be against a CloudFormation template. So this is just an example of what you can do here. So this is a pre-recorded video. It has been sped up a little bit because some of this stuff takes a little bit of time. We are writing the Jest unit test. We're going to create the S3 bucket stack or set of resources for this particular application. And then we're going to add some expectations to this on this stack. We want to make sure that it has an S3 bucket resource. And we're going to make sure that some of the configuration for that S3 bucket is correct. So I mentioned earlier that we want to create a bucket that has encryption enabled by default. And so I've added in some of the properties to make sure that enable this encryption, and then we're expecting certain values for that. So heading over to the terminal, we build and run these tests at the command line. I can see very quickly that there is a compilation error, and that's because we haven't actually written the production code yet. We've only written the test. So here we are creating the bucket, the S3 bucket stack itself. So this is the production code. We're creating the class. We're setting up the constructor. And then this is where we are going to add, we're going to add the S3 bucket resource. We're going to give it an ID and some of that configuration. So we're so that the ID is the ID of the resource within this code. The bucket name is the actual bucket name in the AWS console. We are blocking all public access, and then we'll build and test this again. So now we can see we still have a failure, and that's because I missed a piece of the configuration, the server-side encryption configuration in my production code. So it's just telling me that it's failed. It's showing me the comparison of the configuration for what was expected versus what was actually generated. So I'm going to go into my production code. I'm going to add the encryption configuration, setting it to enabled, and then we'll rerun our tests here. And we have a passing unit test. So that is how we get, we can do that test-driven development flow that I mentioned earlier with our unit tests. Now, we have our infrastructure code. It's been tested. We can apply it to create resources in the cloud. We could go into the AWS console and poke around and check the state of those resources. But if I had 30 S3 buckets, that's going to be a lot of work. I don't want to do that. Um, so, and that could be, across accounts, across regions. It could be more than just one S3 bucket. It could be an entire stack of different resources. And so manually testing that and manually making sure that everything was set up correctly it's really just not feasible for larger situations beyond like one S3 bucket or one EC2 instance. So what we can do is we can actually write integration tests. And this is a form of testing where we are testing interactions across the different units or modules, or in the case of infrastructure testing, we're testing across different cloud resources. So it's going to allow us to verify that we've provisioned these resources correctly. They've been created correctly. They're configured correctly, as we expect them to be. So as I mentioned a lot earlier, the cloud is making it easier for us to scale. But with this complexity, we have to figure out how we can manage that. And integration tests are another way to give you confidence in the actual provisioned resources. It lets you do that at scale, and it lets you do that at velocity. So in just a minute, I'm going to show you another example of integration testing. And this is going to use an open source framework called Chef and Spec for testing, and it's used for testing and auditing your infrastructure. You're able to write tests with a DSL, so a domain-specific language. So we can do this on remote systems like servers. We can do it on containers, and then we can also do it on cloud resources, which is what we're talking about today. It can be used. One of the benefits of this is it can be used on any machine or resource, regardless of how it's managed, or even if it's not managed at all. So it could be managed by CloudFormation. It could be managed by the CDK, which is what we've been using today, or it could be managed by Terraform, or even manually by a human. So it doesn't even have to be managed with infrastructure code. It's easy to read and learn, and it can be used across teams. So for instance, your security team might want to have a set of rules and impact levels that they have set up specifically for how you provision infrastructure in your company or your team's environment, or for certain situations. So these inspect tests, when they're set up that way, we give them an impact level from 0 to 1, and based on that impact level, that can either fail your test or just provide a warning based on that impact. And then again, this is just it adds to how you're able to make sure that your requirements are being met. And it helps you do this at another stage of the software development lifecycle. So in this demo, I want to show you it's possible to test your infrastructure directly, and you can even test drive those tests right alongside your unit tests. So for context, this is another CDK app. There's an EC2 instance and some related resources already tested and provisioned. And now we're going to add a database to this app. We're going to write a failing integration test. We already have a failing unit test, but we're going to write a failing integration test with the inspect framework that I just mentioned. We'll update the infrastructure code, and then make sure both our unit tests and infrastructure tests pass. So if you're familiar with RSpec, unit test in Ruby, these are going to look familiar because it's built on these inspect tests are built on top of RSpec. So for this one, we're going to go into the unit test, and we already have, like I said, we already have our EC2 instance tested. We have a couple of other related resources tested. We've added a unit test for the database that we're adding, making sure that it's set up correctly, and that we have an output of our from our infrastructure code that we can use in future tests. So we build and run this test, and we have a failure, and that's because we haven't updated our production code to include the database yet. So if we go into the production code, we can see here we have all the related resources to create our EC2 instance. We've set up our security group. Elastic IP, and while I was only testing one of those outputs, here we have both outputs that we use in our inspect test later. So then now we want to go into the inspect test, and this is going to look, if you've used RSpec, it looks a little bit familiar. We have that impact level and title at the top. A control on line 3 there is really just grouping. It's another way to group tests or related tests. Lines 10 and 11 are output parameters that we are going to use in this test. So when we create our stack, we want to output certain resource IDs so that we can use them in these tests. We are making sure we have an EC2 instance and the security group and making sure they're set up correctly. Here, we're going to add database outputs. We want to make sure we have that instance identifier and security group ID so that we can, this is so that we can actually find that resource in our account during this test and test against that specific one, that specific resource. We could go through all resources, so all databases that are created, we want to make sure they're set up in this specific way. So there's a different way to get at all resources versus just one specific one. Here we are adding the RDS instance test. We want to make sure that the engine is Postgres, the version is 12.7. We're making sure that the instance class is a T2 small. And then now we can go and run our test at the command line using the inspect command line tool. We can see here we do have a failure. And that is because we haven't actually created that RDS database in our production code yet. So that will be what we do here. We're importing the resource class. And then after our EC2 code, we're going to add that RDS database instance and set that up how we need to. So we're going to give it an instance identifier. We're giving it the engine, the version that we are expecting, a few other bits of information. We're going to tag it, and then we're going to set up the connection so that our EC2 instance can actually talk to our database. And the video is paused. I'm going to just talk through the rest of this. Oh, here we go. Okay. And then we're adding those outputs. The outputs are used for again, they're used for that inspect test so that we can assert against specific resources. And then, so this is where those outputs actually are when we've run our CDK code. The actual values get put into this file. And then we are importing those in our inspect test. So now we run our unit test again. We make sure that passes. That's passing because we've added our database. And now we are able to, we're going to actually deploy our application and just passing in some parameters here, telling it where to put those outputs. And this takes a little bit of time, obviously. So this has been sped up so that we don't have to sit here and wait. And then once we have our stat created successfully, we can run our inspect test. And we have a successful inspect test. So we can see that the database has been added. The test is asserting the configuration is correct. We've used both our unit test to make sure our code is written correctly, and then we've used the inspect test to make sure that it's been provisioned correctly in the cloud. So I've got a couple more slides left here. I'm going to go through this one really quick. Drift is what happens when your resources are actually they get out of sync from what your code says. So we want to make sure that we have ways to detect drift, and many of these infrastructure as code tools do not let you they do not let you manage drift or detect drift of resources that they don't manage. So in the case of this example that I just showed you, I had an EC2 instance and an RDS database with related resources. But if I had any other resources in that account that are not managed under that code, I would not have any way to actually determine that my resources have drifted or are out of sync or out of compliance even. And so we can actually use Inspect to detect that and to help us manage that. So again, like I mentioned earlier, like the security team can make sure that certain resources are configured in a way that is compliant. And we can do the same thing with how we expect our configurations to work as well. Now we've talked about all this testing, automated testing. You might be wondering, we have all these tests, what do we do with them? Today, your process might look like this if you don't have automated testing or if you're only finding your issues in production. You are waiting until it's actually in production before you are figuring out if it's working or not. And sometimes it might be that you haven't found that a resource isn't working or it's not configured correctly, but your customers have found it. And we don't want our customers finding our issues. We want to find them for them before they find them. So infrastructure as code, it plays a key role in our CI/CD. It relies on infrastructure automation to create consistent environments, and it lets us be confident that what we built works through each environment, each stage, and it's also going to work in production. So what we can do is we can actually add our automated infrastructure test to our CI/CD pipeline. We can iteratively develop, run our automated unit tests, run our integration tests, and then deploy our infrastructure itself, not just our application code, but our infrastructure through each environment, just like we would our application code. So by moving our infrastructure tests earlier in the pipeline, shifting it left, and doing it at every stage, we're going to find bugs earlier in the process. They're going to be cheaper and easier to fix. One last thing I want to leave you with is that we have our infrastructure code is actually code, so we should be treating it that way. We can code review it, version control it, test it, whether it's integration tests or unit tests. We can push it through our CI/CD pipeline as well. Testing is not ever done. We should be testing it at each stage of our development lifecycle. But if you're not testing in production, your customers certainly are. So that's one reason why we really want to have these tests earlier in the process, is we can catch them earlier and it's going to be cheaper to fix. And that is all that I have today. Thank you for joining me. I appreciate you all being here early in the morning. Please give me a follow or shout out on social media. The link to the code is here at the bottom for the demo if you're interested in that. And if you have questions, please let me know. Thank you.
Thank you, Jenna. That was a great talk and something near and dear to my heart. We are a bit up on time, so for Q&A, if people wanted to take that to the chat, that would be great. Thank you again, Jenna. That was a great
absolutely. Thank you.
Thank you so much for coming on today.